It's 6.2, and it's the log cosine. Non-right triangles. So what we're going to do here first is we're going to examine what the law of cosines is. The thing that we just did with the area of a triangle, this is sort of similar in concept because it's going to involve the same formula three different ways based upon what information is given. So we're going to say that side length A squared is equal to side length B squared plus side length C squared minus 2 times BC times the cosine of angle A. And then I want to analyze this a bit. Because since you're going to need to memorize this one, and you may have already last year, but you're going to have the chance to now because you read on the test here. Okay? Let's analyze what's happening. We have a side length here, and the angle that's cosine matches that side length. That's what runs the rest of the whole thing. Whatever side length here is, tells you what angle you'll do the cosine to. The other two, both are squared and added, and here it's minus 2 times those. So you want to just remember that part and just plain flat out memorize it. And after you do it a few times, it's really not that hard to memorize. Like always, I recommend if there's something you need to memorize for a test, when you come in and sit down, you get the test, you sit down, either on the test or grab a piece of paper and just write out all the formulas you knew you'd have to memorize. Then you don't have to think about them during the test. You have them written down right at the beginning and you're set to go. Because, 35 minutes into the test, you run across a problem, and 40 minutes before you had it memorized perfectly, all of a sudden now you can't remember any of it. But if you'd written it down, you wouldn't have had to worry about it. So I recommend to do that. Science and math especially, those are like the things to do. Now, this is true if it's A squared. Well, what if you don't have that, but you have B? So you know it's B squared. Well, that means it's going to be cosine B. And instead of B here, it'll be A there. A squared plus C squared minus 2AC times the cosine B. And you know where I'm going with this. Let's say this is C squared. Go ahead and write it out yourself for C squared. Because it'll be the same idea, but now it's C and angle C. Now, let's use this. Now, oh, by the way, notice this formula allows you to use it if you have two angles, two sides, and the angle that's in between those two sides. The A and C would have B in between it, A and B would have C in between it. So it's sort of like I drew on that little paper a moment ago. When I drew this with the area of the triangle, it was an angle with the sides, with the two side lengths, so the two side lengths and the angle in between them. That's why this one could have gone with this section, except there's another one at the end of this section that we're doing more. Okay? It also can work out if you're given, instead of the angle, if you're just given the three side amounts. You can still do this one. And that's actually one of the examples that I give. There are two examples here, one of which is with an angle. Let's do this. I'm going to tell you A equals 28 units, B equals 15 units, and C equals 82 degrees. That's all we need to know, because we now know two sides and an angle that's in between them. That means we can use this one right here. So I'm going to say C squared is A squared plus B squared minus 2 times A times B times the cosine of 82 degrees. I'm doing very good today because like I'm sure you have, there's certain kinds of problems where you sometimes make the same kind of error at the same time. You write the same thing, and you write it down wrong, and there's always something you have to catch yourself all the time. One of my biggest failings is when I write this out, for some reason I want to write sine every time. I'm always writing that. So this is one of the first times I have not had to correct myself, and I've gotten cosine all the time. Now, having said that, I hope I don't jinx myself. Let's see what happens the next few minutes. So that's all just calculating. You square those numbers. If you're doing that in the calculator, you should see that 784 plus 225 minus 840 cosine 82. I'm going to keep going in a minute, but I'll tell you, chances are very good that there's an error here that you will not make. But there's an error that lots of people do. And it's that, that 784 plus 225, what happens here is that lots of times people do that. 784 is that 1009, is it? Okay, that was 75, it would be 1,000. So I think it's 1009 minus 840. I just did that by head, so I'm hoping I'm right up. What happens here is it's just too tempting for some people. Some people are just too tempting and they just do this. They do 1009 minus 84 before they multiply cosine of 82. So be careful about that. You know the order of operations. You know that you multiply this first, but it's just very tempting to see that. And I don't think any of you will make that mistake, but I'm just sort of forestalling it, making sure you watch out so that you do this first. Okay? When you get that all done, you get c squared is approximately 892. So you do that, multiply to 840, subtract it from 1009, you should get about 892. And then you take the square root of it. Take the square root of both of them, and you see that c is approximately 29.9, or so close to 30, we can say 30 units. Okay? So we've now figured out what c is. Okay? So that's c, but we have to solve the triangle. So what I should have written here is solve the triangle that has 28, 15, and 82 degrees for those three. We now have the third side. Now we have to go, one of the next steps, we have to find an angle. So even though we did the law of cosines here, we're back to the law of sines, because we have an angle and its side length. So the law of sine says sine c divided by c will give us sine A or B over the other one. So let's set that up and let's do that. Sine of 82 degrees over 30 is equal to, which one? Doesn't really matter. Sine of, I guess I'll take A just for the fun of it. Sine of A over 28. So it's sine C over C and sine A over A. Oh, I put 28 and I'm supposed to put, yeah, no, it is 28. Second guessing myself. So now we'll cross multiply, okay? And I'm going to get that sine A is equal to sine 82 times 28. So sine 82 times 28, this was sine times 30, and I'm just dividing by 30 before I'm even writing it down. So it's sine 82 times 28 divided by 30. Sine minus 1 of all that will be equal to A. So rather than rewrite it, I'll just tell you that you're doing the sine negative 1 of that. And when you do all that, you get that A is approximately 67.5 degrees. So we now have all three side lengths, and we have two of the angles. And if we want the other angle, it's just 180 minus 82 minus 67.5. Okay. Minus 82 minus 67.5 gives me 30.5. So that would be B is equal to 30.5 degrees. So this is actually a good common example If you're told to solve for the triangle and you're given two side lengths and the angle in between, you use the law of cosines, but then you use the law of sines afterwards. So the law of sines is actually usually, I guess you say percentage-wise, it's the more useful one, except you wouldn't be able to solve this one without the law of cosines in the first place. So you have to use both of them together in this case. All right.